Okay, here we go, another question. This is going to be path in Zigzag labeled binary tree. Let me see if make sure the stream is working before I begin. The audio is working. Labeled binary tree. Yep, audio is working fine. Very good. All right, just give me one moment here. Make sure everything's working. Yeah, I think we're good to go. Okay, so very good. Path in Zigzag labeled binary tree. Close this one, and we'll also refresh this one. Okay, so we just finished our last question, starting the next one. Path in Zigzag labeled binary tree in an infinite binary tree. Whoa, okay. Where every node has two children, the nodes are labeled in row order. In the odd numbered rows, i.e. the first, third, fifth, the labeling is left to right. Excuse me. Labeling is left to right, while in the even numbered rows, second, fourth, sixth, the labeling is right to left. Okay. Given the label of a node in this tree, return the labels in the path from the root of the tree to the node with that label. Interesting. Excuse me, I had some milk from before that I did not finish. All right. Label 14, 1, 3, 4, 14. Label 26, 1, 2, 6, 10, 26. Oh, I think I understand. Okay. And their label is going to be between 1 and 1,000,000. So they want the path to the node. So the odd numbered rows, labeling is left to right. Even numbered rows, labeling is right to left. Okay. Interesting. So 14 is here. So we need to go left, left, right. Okay. Interesting. 26 is the next layer down. And that's going to be yeah, what's the value in the left and right? Well, I mean, I could try to convert the position and just look for the position. That might be easier. That's probably a lot easier, actually, if you just do it that way. So it's just, if it's odd or it's even, we reverse the position. So if it's even, 1, 2, 3, 4. Oh, I see. How do we know how if it's even or odd? I think we want to use logarithm, right? Floor base log 2. We can use a some built-ins to do the log 2 floor. Log 2 floor could be whoops. This is going to be x is 0. Zero return -1, otherwise it's going to be like CL something or other, CLZ minus CLZ. Dunder. I think that's it. CLL is for long. I think that's it. I don't know if I need. Give me a second, let me double check that. I think I can check it this way actually. For GCC is probably what I want. Yeah, built-in CLZZ, LLC. Huh. What am I missing here? Built-in CLZ. There it is. Built-in CLZ is what I want. It's gotta be unsigned, huh? Oh, I see. Built-in CLZ L and LL. I just need built-in CLZ L. Okay. What does it do? Turns the number of leading 0 bits in X starting at the most significant bit position. If X is 0, the result is undefined. Yeah. Okay. So it's going to be built in. And and yeah, it's a long. Well, we have an int, right? CLZ. Okay. Oops. Built-in CLZ. CLZ and then L and LL. Oh, okay, I see. Interesting. Right. The way this works is you would say if, let's say you have 32 bits, right? I think it's the other way around, actually. Other way. And what does it say? It's X is 0, the result is undefined. Oh. Starting from 1. Okay. So if you have a 1, it's 32 bits. You're gonna have a third. This will always be a 31, right? And then here, let's say it's like 4, right? So that means the bit is going to be shifted over two positions to position number 3. That's going to be 32 minus 3 is 29 zeros, right? So we do 31 minus 29. You get 2. Which is basically the number of bits to the right of the most significant 1 bit. Yes, confusing, but yes. And that gives you the logarithm. The index of that bit is the logarithm, right? Which is exactly what that'll be. The index of the most significant bit will be the floor of the logarithm, log2 floor. Yeah, it's a pretty interesting function. It's kind of involved. But anyway, all of that is to say we can take the label and that'll give me the depth. So if the label is like 17, let's say, the log2 floor would be equivalent to the log2 of 16, which is 4. And so that's going to be 1, 2, 3, 4. That's actually going to be 1 larger, I think. I think I want depth minus 1. 0, 1, 2, 3. And actually, this would be too large. It would be 1, 2, 3, 4. That would be the next 0, 1, 2, 3, 4. Actually, yeah, that's the right spot. Yeah, that's fine. So starting from 0, that gives us, and so odd numbered, let's do, really it's going to be left to right is 0 index, 0, 2, etc. Really would be the even indexed, even 0 indexed, and then odd 1 indexed would be odd 0 indexed are going to be reversed. So we'd say if depth and 1, we do one thing or the other. So if it's if the position is, if it's even, if it's 0, then the position is going to be just say int position is just label, right? I think also it's going to be, we're going to subtract 1, right? And if it's not, or excuse me, yeah, so if it's odd, then we're going to update that position. I'll explain what I mean by this. Yeah, so subtract 1, be 0, 1, 2, or 0, yeah, 1, 2. 0, 1, 2 would be the position normally, but if the depth actually has a 0 index depth is odd, then we're going to swap the last section. That means the position is going to be basically take depth minus 1, right? Bit shift that. A power of 2, that's how many elements are going to be behind this. So we said the depth is 0, 1, 2, 3, 4. Depth of 3 is going to be 1 plus 2 plus 4 plus 8 is 2 to the 4th minus 1. So it's actually going to be 1 to the depth minus 1. Or 2 raised to the depth minus 1. So if we got 16, 0 to 15, well, yeah, it would be 15 elements. These positions are actually 0 to 14. That's what comes behind, right? So we'll say previous. And then we're going to take the position and subtract the previous amount. So again, if the position is, we said 26, right? So it'll be some number 25 somewhere around here. What's going to happen is, since it's reversed, what I want to do is take that last section, which is going to be from whatever the depth is. So here the depth is 0, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 2 raised to the depth, number of nodes. We'll just say level size is that. Previous is going to be the level size minus 1. Level size is significant because it basically means that the, let's say, level index is going to be position minus previous, right? So again, if we had 14 was the largest, and let's say we were looking at 15 and 16 here, right? 15 minus 14 would put me at 1. It's actually going to be Okay, already subtracted 1 here, right? Gave me 16, it would already be at 15, and 15 minus 14. I think, no. I would subtract 15. Yeah, that's fine. If it's 16, I would be subtracting 15. Previous is the level size minus 1. That's really confusing. Yeah. So level size, 16 minus 1 is 15 elements. Subtracting 15 from 16 puts me at 1, but I already subtracted 1 from 16 anyway to put me at 0. Okay, I think that makes sense. I think we're fine. So this would put me at the level index, right? Normal level index. Now this level index should be reversed. Reverse level index is going to be the level size minus the level index. Now the new index is going to be previous amount plus the reverse level index. That's all of that. What all of that is supposed to do. So I guess if you're going, 1, 2, 3, 4, 5, 6, 7, and you're given an 8, right? The level size is 2, 4, 6, 8, right? That's the level size is 8. And then 8 minus level size minus 1, which is minus 1, and then there's another minus 1 normally to make this 0 indexed. So we're put at 0 is index 0. Its reverse level index is then 8 minus 0 is 8 over here. Oh, all the way around. Or not all the way around, but subtract 1. Yeah, I forgot. That's to reverse. You take the size minus 1 and subtract the index. So that's what that's supposed to be. That's what that's supposed to be. So now it's so 0 index, we end up with 7, and now we add the previous amount plus 7. So the previous amount is we said level size minus 1 puts me at 0 to 7, right? 7 elements, and then now we add 7 to that, which puts me at 14. Index 14. Should be index 15. This actually needs to get a plus 1. Like plus 1 plus the index. Yeah, that gets confusing too. So to go from the previous elements, we add 1 to get to that first index, that next index. Yeah. No, index 7, no, that's fine. No, index 7 is this spot. And then we're actually adding indices. We add 7. That puts me at index 14. So you're 7, 8, 9, 10, 11, 12, 13, 14. Oh, it is 14. 7, 8, 9, 10, 11, 12, 13, 14. Oh yeah. Okay, I was right. I was right the first time. I got it. Now we can just do lefts and rights for the position. So I think we do bit by bit. When we see a 0, we go to the left. When we see a 1, we go to the right. Yeah. Is that right? We'd have to reverse the bits. I'm trying to remember how this works. So if I have a 5, that's like 1, 0, 1. I don't know. 5 minus 1 is 1, 0, 0. Yeah, 0, 0. Each 0 just multiplies by 2. 0, 1, 2. Multiply that by the index by 2 and add 1 here and add 2 here. Multiplying by 2 and adding 1 goes to the left. Multiplying by 2 and adding 2 goes to the right. It's a little bit confusing. You start at 1, 1, it would be just multiplied by 2. Yeah. So you see a 0, you just go to the left, and 1 is to the right. Is that, trying to think here. All kinds of off by 1 things going on here. It's taking me a while to think this through. Already been at this for 20 minutes. I'm pretty sure that's how this works. Oh, you know what's really awkward about this is the positions themselves are reversed here too. Oh no. Oh, that's awkward. Well, you could just do left, right. Yeah, that's fine. Is that fine? Is that fine? I don't know if that's fine. Does that work out okay? I don't know if that's okay. Not too many submissions, a lot of accepted answers. I think what I'd want to do is yeah, you could figure out which direction we're going to go in just by processing this position, but it's not so obvious what the value should be. So I think that's a good question. Oh boy. What should the value be? 0 is going to be, well, it's going to be every other spot. It's going to be the same value of that position multiplied through. But I think you could just do an adjustment to the number on the reversed sections, which isn't too hard to calculate. Yeah, I think so. 10 to the 6th is only like 2 to the 20th, right? Yeah, which is like a billion. A billion, 2 billion, that should be fine. Okay. So let's do the following. Let's say const int length is again log2 floor, most significant bit position of position, right? Which could be 0. Otherwise return 0, so return 1. And we're going to say for I is 0, I is less than length. We're going to increment I. We're going to take a bit, it's position in 1, and we're going to it equals position in 1 of a current spot equals 1 to current position 0. Say if bit, then we say current position bit shift 2. There we go, I like that. All right, so that's my current position. And I've got this vector result. And normally I would say, so if I and 1, okay, current position plus 1 puts me back at the kind of normal value, and if not I and 1, so if I and 1, we do one thing. If it's 0, we do the other thing, right, which is this. But if it's a 1, then we get to perform the adjustment, right, which basically means we do the same kind of adjustment we did here, which is get the level size, just 1, the shift to the left of I, which is the depth. Then we say take the previous amount, which is level size minus 1, get the level index, which is going to be our current position, minus the previous value, get the reverse level index, level size minus 1 minus the level index, and then we set the current position, say temp position is previous plus this R level index, and then result pushback T position plus 1, which is a little confusing, I realize. So yeah, it's pretty involved. It's pretty involved. I think it's logarithmic in terms of time. I got 1, 4, 1. Should be 1, 3, 4, 14. Oh, jeez. Of course. Where did I get 1 from? Oh no. Okay. Excuse me. Okay, what's the position? Start with that. Position should be 0, 1, 2, 3, 4, 5, 6, 7, 8. Position should be 8. Because that may not be calculated correctly. I've been doing it on time. This is a lot more complicated, this approach and this idea. Okay, got 8. That's good. So that's working. I think this log 2 floor might be wrong. So log 2 floor of 8 should be also good habits. Good habits. That should be 3, right? Yes, there's 3. Okay. That's not actually what I want. I want plus 1. Yeah, I actually want a plus 1 there. Or equal to 3. Yeah, equal to the length. No. Yeah. Let's try that. Oh, okay, a little bit better. What do we get for the length? The length is 3, okay. So current position starts off at 1, or 0, and then goes to 0, goes to 1. 0, 0, 1. So I think I did this wrong. It's actually plus 1 plus goes to 0, 1, or 2. That's what it's supposed to be. Okay, 2187. Also, I think this is supposed to be here first. And then we update these two. And maybe I'm wrong there. 1, 3, 4, 15. So close. It's a little bit off in both cases. Okay. So I think both is always going to be a 1 initially, right? Yeah. So 1, 3, 4. Okay, 1, 3, 4. And then now, after adding 4, current position is 1 to 1 to 3. Yeah. 3, and then after 3, it goes to position 6. 3, 4, 5, 6. Goes to position 7, 8. Goes to position 8. Let me see. Current position. Yeah, this is not the easiest thing to do correctly. It's definitely pretty involved. If I've done this like a bunch of times, then I think it'd be easier, but this is sort of first time doing exactly this. 0, 1, 3, 7. 0, 1, 3, 7. It should be 8 actually here, not 7. Oh, not position. Oh no. I did that wrong again. It should be I. Should be I. Excuse me. Let's say flip. Yeah, that's what it's supposed to be. Actually, no, that's not correct either. No. Okay, that's wrong too. Bit is, this is right. This is supposed to happen. That's my mistake. Make mistakes sometimes. Okay. 1, 2, 3, 4. Oh no. 0, 0, 0, 1. Is that right? Something's wrong here. Yeah. 1, 2, 3, 4. I think I'm supposed to add. I think I'm supposed to calculate this beforehand. I'm so confused. Something's wrong. 0, 0, 0, 1. Something's not right. Oh, boy. Oh. Oh no. I did something wrong here. No, something's not right. Excuse me. Let's make this a little bit simpler. Something's wrong. I don't know exactly what it is. I don't realize what it is though. It's some kind of off by one error, but no, it's not. It's a logical thing. How do you go from a position in like if I number my nodes from 0 to n minus 1, left to right, top to bottom, and then I'm given that index and I want to search in the binary tree for that particular index. And suppose it's a full binary tree, right? Full and complete binary tree. It should be very straightforward to be able to do that. And for some reason I'm just kind of blanking out on how to do that exactly. Looking for an 8, you go to 3, 7, 8. Right? From 1 to 0 to 1 to 3 to 0, 1, 2, 3, 4, 5, 6, 7, 0 to 1 to 3 to 7 to 8. 0 to 1 to 3 to 8. Yeah, that's fine. What's the problem? This is 0, 0, 1 though. That's 2 to the third is 8. 0, 0, 1 is 4. Oh, that's the problem. I think I see the problem. I think I'm seeing it. A little bit confusing, but I think I see it. Well, gee. Well, gee. Do we just have one less bit to work with? Like, what about 9? What if I wanted to get to 9? 8, 9, you still go 0, 0, or 0, 0, 1, 1. No. You go 0, 1, 0 to get to 9. 0, 1, 0. What the heck? This is so confusing. Why am I getting this wrong? Something about this is not making sense. It's supposed to just be process the position bit by bit. I think it's supposed to be reversed. Might be part of the problem. Oh. What the heck, man? Excuse my language. Excuse me. I don't know. I'm suddenly very confused. Is it supposed to be reversed? Is that what it is? No, I don't think so. No. Nope. I'm missing something important here. Somehow it doesn't make sense. Yeah, first off, you get 4 bits in 8 with 2 to the 8th, 2 to the 3rd, right? Because you have 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd. And that 2 to the 3rd is set to true. It's 4 bits, not 3. Yeah, so it'll be log 2 floor plus 1. And then, okay. So, excuse me, what are we doing here? I think I'm supposed to add the bit and then shift it. Yeah, so it'd be more like 1 than 0, 0. Is that right? I don't think that's right either. Ooh, excuse me. Well, that would get me to 8, starting from 1. 1, 2, 4, 8, right? Something's not right here. I think the zeros are supposed to go to the right. Actually, I think that's the part that's confusing. No. No, if you number on the, no. 1s go to the right. 0, 1, 2, 3, 4. Yeah, children, you multiply by 2 and add 1, or multiply by 2 and add 2. So, how do I get to 8? How does that? Zero, 1, then that goes to 3, depth 2, but 3, and then depth 4 goes to 8. We'll go to 7, but really 8 in this case. That's a depth of 4. I think the bit gets added before the shift occurs. I think that's the way to do it. It's so confusing. Why? Oh, this doesn't make sense. I don't know. I'm missing something important. I don't see it. Kind of tired too. What is going on here? Why is this so difficult? How do you make a position number, right? So you would have a 1 and then you bit shift it to go up to 8. So if you reverse that, you would get 8, 4, 2, 1, 0, right? Excuse me. I think that's part of the problem here. Is there is an analogy with bit shifting and adding and whatnot. If you take a number that's a 1 and you bit shift it, that would be like multiplying by 2. And then the next bit, you either add 1 or add 0. If you add bit shift and add 1, that's sort of like bit shifting and inserting a 1. And if you bit shift and don't add 1, it'd be like bit shifting and adding a 0. And so starting from 1, yeah, you could just bit shift 3 times to get to 8. That should be it. However, that's if you start from the nodes labeled with a 1 rather than labeled with a 0. If you label them starting with a 0 indexed, I mean, you just pretend that they're 1 indexed. Why is this so hard? Why am I struggling with this so much? I'm pretty sure I've done something like this in the past that wasn't this difficult. And for reasons that are beyond me, I'm really struggling here. In that case, the 1 indexed position is not a. It's not a. Well, you can convert the 1 indexed position, 0 indexed position to a 1 indexed position for this purpose, I think. I guess that's fine. Just add 1. So the 9th position. So to get from 1 to 9, you would bit shift 1 to. So you would add 1 when you bit shift, right? Because you'd have 1 0 0 1. Also, that's a palindrome, which makes things more awkward. But let's say it was a 10, so it's 1 0 1 0, right? Let's do it that way. Let's try 10. To get from 1 to 10, you would, I think, multiply by 2 to get 2, then multiply by 2 again. This time add a 1. 1 to 2 to 4 plus 1 is 5. 1, 2, 5. And then bit shift one more time. Bit shift once. Add a 0. Bit shift again and add a 1. Then bit shift one more time. Because you start off with adding a 1, right? That's confusing, huh? Yeah, you're going to go from a 1 to a 1 0 1 0, right? You're going to shift the 1 over 3 times, but also put I think it's supposed to be reversed, man. That's so confusing. Yeah, I think if you reverse it, it makes more sense. So 10 reversed. It's more like 0 1 0 1. And then you push, bit shift and add a 1, bit shift add a 0, bit shift add a 1, bit shift add a 0. Yeah. Yeah, I think I'm supposed to just reverse the bits. So if I do that for 8, then I end up with 0 0 0 1. So I would bit shift and add a 1, starting from 0, would get me at 1, position 1. And then bit shift again and add a 0. Puts me at 2, position 2. That's wrong though, that's not the correct path. That's not the path at all. It's so confusing. What is going on here? What a headache. This doesn't make any sense, huh? Oh, 0, position 1 is, yeah, okay, position 1 is like, no, that's fine. I get to position 1, then I get to 0, 1, 2, I think 3. Position 3. That doesn't make any sense. Excuse me. I don't know. I have to sit and think about this for a while now. I'm not seeing it. I mean, I could just convert this to. It doesn't make sense though. There's something to this, but it involves an off by 1 error of some kind, I'm sure, or just something I'm not seeing. Something I'm not seeing. There's some kind of analogy between the bits 0 and 1 and going left or right in the tree. That's like the important part, but what exactly that is not so obvious. I think it's as simple as, look, you just take a position and index, and when you divide by 2, you go up the parent, right? Yeah, and if there was a 1, then you're a left child. If it's a 0, you're a right child. Or the other way around, if it's a 1, you're a right child. If it's a 0, you're a left child. The bit that was just removed. So to go backwards, so to go up the tree, you bit shift to the right. Go down the tree, bit shift to the left, and add the bit that's supposed to be there. And it's exactly the reverse, right? So you can actually push all these bits onto a stack, and then shift and push and add the bits on the stack to get to get back to the original number. Is that right? That seems a bit odd. Okay, so again, if we had 8, it's 0, 0, 0, 1, right? So starting from 8, bit shift 1, we get down to 4. Which is not correct. No. No. If I make the node 0 indexed, you've got to subtract 1 and then divide by 2. Bit should divide by 2. Yeah. So 8 becomes 7, and then you divide by 2 and you get 3. Then you bit shift. So you subtract 1 and then bit shift. That's what it is. It's subtract 1 and then bit shift, and then subtract 1 and then bit shift a bunch of times. And if there was a 1 there, when you subtract 1 and bit shift, then you're on the right side as a right child. That's why it's so confusing. Excuse me. That's why. Now I understand. Now I understand. Yeah. So from a zero index position, what I put on this push on the stack is actually after subtracting 1, then checking if there's a 1 or a 0. And if there's a 0, that's actually, that means that it was on the right. It means that there was a bit there. And then if it's a 1, that actually means that it was a 0 and some bit flipping had to have occurred. It was on the left. Oh, that's really confusing, huh? Excuse me. Yeah, that's pretty confusing. So the correct sequence would be 8, subtract 1, and bit shift. 1 goes to 7, bit shift down to 3, right? Then 3, you subtract 1, goes to 2, bit shift down goes to 1. So 8 to 3 to 1. And then again, subtract 1 and bit shift, you get down to 0. That's exactly correct. And the reverse sequence, so 8 is even, which means it's on the right. So you have a 1 to represent going to the right. And so what gets pushed onto the stack should be 1. And then you subtract 1, bit shift 2, take another look. And if you have a 0, which actually 3, you have a 1 again. You have a 1, pushes 0 onto the stack to signify going to the left. Then subtract 1, divide by 2, you get a 1 again. Again, 0 on the stack. So now the stack has 0, 0, 1 to signify going to the left. And then finally, subtract 1 and divide by 2, get back to 0. So it goes 1, 0, so that's 1 to the right, 0 to the left, 8, 3, 8, 3, 1, 0, 8, 3, 1, 0. And that gives me 1 to the left from 8 to 3, going back, or rather 3 to 8 is on the right side, 1 to 3 is the left side, 0 to 1 is the left side, so it's left, left, right, which is just 0, 0, 1 on the stack. And then when you process the stack, you go in the other direction. You go from 0, go to the left, because this is 0 on the stack, which means multiply by 2 and add 1. I can get to 1, and then another 0 means multiply by 2 and add 1. So you go to 3, and then there's a 1 on the stack to go to the right, multiply by 2 and add 1. Right? Or excuse me, multiply by 2 and add 2 to go to 8. Oh man, that is so confusing. Oh, I get it now. I get it now. But wow, that was kind of a mess. It was very messy. I think I understand what I did wrong now, though. Still logarithmic time, but definitely way more complicated than I initially thought. And that took me like a full hour just to work through all of that. Yeah, it's not the length, actually. It's going to be just the stack. let's make a stack. So we're gonna say for each position greater than 0, we're gonna say position -1 is position -1 right? Right. Okay, a little bit involved here, but something like this. Okay. It's going to be, if you subtract 1 and there's a 1, so if it was a 0, basically just bit flip this. If you see a 0, it should be a 1, right? So if you subtract 1 and you still see a 1, that means it was a 0. Could do it this way. This is maybe easier. Yeah, confusing. So let's say we had 8, right? And then we subtracted 1. We go down to 7. We take the AND with 1 to check the bit, and we see that it's a 1. That means that when we multiply it by 2, I don't know. It's the other way around. Oh, that's so confusing. So confusing. I think it's this way, actually. I think it's this way. Oh, it's confusing. So 8 is on the right side, which means I want to have a 1. Yeah, I want. Oh, no, I had it right the first time. I had it right the first time. 8, yeah, 8. When I subtract 1 from 8, I get something that's odd, which means that 8 was even. The even thing should give me a 0, or the even thing should give me a 1. That means we go to the right. The odd things means we go to the left, and we should have a 0. Yeah. Right. So after subtracting 1, it should be even. This should give me 0 if it was odd, right? It's maybe a little bit confusing. And then if the position is 0 initially, the stack is just empty. And so we always do, we typically do this part. I think I'm going to put first just going to put result.pushback 0 or 1 always. Just always do that. And then if it's empty, then that's fine. And then this happens. We don't have this position thing going on here. Current position I, we don't really need I. Yeah, just like that. It's fine. Something along these lines. Bit confusing. Oh, maybe I do need I. Okay. Forgive me. Boy. Okay. Still wrong, but a little bit closer. Oof, neck here. 1, 3, 4, 14. Should go to 14 here. You just always push a 0 at the end. Close. Closer. Still wrong. Huh. Maybe this is supposed to happen first. Maybe that's what I'm missing. I don't know. I don't know. Okay. We'll come back to this. I'm missing something here. 219. No. What did I do? What did I do? Oh boy. Maybe this is supposed to be. Maybe it's supposed to be this way. That could be it. I don't think that's right, but maybe. Oh, that was it. Of course that was it. Of course. What? I mean, yeah. What? I guess that makes sense. So, what is going on, man? There's a 0 at the bottom of the stack. What? No. What? What? 0 means you go to the left. You always just go to the left? You don't always go to the left initially. What about if you go 1, 1? What goes, wait, do these always go to the right? What is going, wait a minute, what? 1, 2, 6, 10, 26, somewhere around here. All right, what about this one? Oh yeah, 1, 3, 4, 14, okay. What the heck is going on? I don't know, let's go like 35. Why does this work? What did I do? It shouldn't work. What is going on? No, man, what? Huh. This doesn't make any sense. One, 3, 1, 2. Why does this work? This shouldn't work. What is happening? What is going on? Part of me feels pretty good that I finally got it, but another part of me is like, this doesn't make any sense. What about when the position is 0? What about like 1, 2, and 3? Let's try these. Let's get something interesting going on here. this might be correct, but I think it's right. I think it's right, but what is this? What is this? What do you mean it's right? What? What is going on? So what's supposed to happen is you process the position, and while it's greater than 0, you push. You end with 1 and push. And the idea is supposed to be that you go. Basically, you're supposed to be going backwards. So, if you have an 8, for example, at the bottom, that's supposed to go to the right. So when you're supposed to divide by 2. You're supposed to subtract 1, divide by 2, right? To go from 8 to 7 to 3. So 8 to 3 to 1 to 0. 8, 3, 1, 0. Okay, so you got 3 transitions. 8, 3, 1, 0. Okay. I think, you know what I think? I think I just need to have this extra 0 in here to make sure I perform the first push on the result. Yeah. And the bit is 0, so we just add 1, multiply by 2 and add 1. That doesn't, no, I don't know. I don't know what's going on. I don't know, man. You know what it might be? It might just be an extra 0 to print the last value. Oh, that could be it. Oh, that's it. Oh, that's why. Oh, this doesn't matter what this is, if it's a 1 or a 0. I was wondering, I was like, what is going on here? Why is this? Chip Jones, my friend, is just watching this little... Oh, my mind is fried just watching this. Oh, I see. Hey, what's up? How's it going? Oh, I see why. Okay, this is just print an extra character. Print 1 more. Yeah, this doesn't actually do anything. Okay, I was gonna say, I was like, this doesn't make sense. This shouldn't do anything. It's just to print 1 more, which is here. It actually just runs this an extra time. That's interesting. Oh, okay. I think I got it. I'm gonna go for it. I could be wrong, but I think it's. Let me just try a bunch more things. A bunch more. Let's do 10,000. Let's do 1,000,000. Let's do like 200. Let's do 5. Let's do 20. And let's do some, random sequence. 123,423. Loving these streams. I figured that I can no longer really do these quickly anymore. These emotes are in the way. Now that I just don't study anymore for interviews. These are always pretty hard to do quickly, quite frankly. Hey, you got there. Sweet. All right, I'm going to submit this 4 more times, and then and then I think that's probably it for me. That was quite a that was tough, man. That was kind of a rough one. There were quite a few things involved. Excuse me. So I have something for you as far as doing these quickly. It's you shouldn't really be able to do these quickly generally. The reason is, 1, they're pretty hard, but 2, a lot of these questions, like the really hard ones, the much harder ones, they're actually, they tend to rely on, oh, that's interesting. So a few times I got 0 milliseconds, but a few times I also got 3 or 2. They should be pretty fast because this is logarithmic time, log of the label. It's basically, yeah, it's relatively efficient. The reason why you should not really be able to do these quickly, unless you've seen it before, is some of these questions rely on research that other people have done. And I can actually point to some good examples. So like a good example would be the longest common subsequence. This is something that I like to refer to. See, it's one of the problems, right? You see that it came up on LeetCode, but it's also it uses a oh no, longest common subsequence. Excuse me, substring is the one I was thinking. Actually, this one I don't know the answer to either. I have to learn this one. But it's considered to be it's NP hard. Oh, I was gonna say this is kind of a hard question. Arbitrary number of input sequences. It's a constant. It's solvable in polynomial time using dynamic programming. Okay. Arbitrary number of input sequences. Methods with lower complexity. Length of the LCS. It's not necessarily unique. Number of common subsequences exponential. The length of the inputs. Algorithmic complexity must be at least exponential. Interesting. As optimal substructure, dynamic programming memoized. Cool. This is a lot like the edit distance, actually. I think that arguably this is a generalization of the edit distance questions, which I think you could prove is quadratic. But anyway, the reason I brought this up is the reason I made a mistake. It's not the common subsequence I'm looking for, but I'm looking for substring, this one. This, you could solve this. There's a few ways to solve it. I don't know, there's a way that I came up with that's maybe not the same thing as this one. I know it's O of n plus m log of n plus m. There's a solution you can do, but what I'm trying to say is that there's a generalized suffix tree that you can use to solve this allegedly in n plus m time, right? Which this is a data structure that's not something that you would bring up or create on your own. This also has different algorithms to create it efficiently. The point being, this is stuff that researchers came up with, right? Like if you were going to figure out the solution to the longest common substring, you either have to, and you're going to do an O of n plus m time with a generalized suffix tree, then you'd have to invent a generalized suffix tree on the spot within a few minutes, and then also invent, Conan's algorithm or McCrate's algorithm or what have you, or your own algorithm to produce a generalized suffix tree efficiently. And then you'd have to know how to use that to solve this question. And the reason I bring this up is because I actually did come up with a solution. It took me like a day or two to this question that runs an expected time O of n plus m times log of n plus m that doesn't use the generalized suffix tree. And I was very proud of that. Uses rolling hashes and hash sets. It was very, and a binary search. It was very clever, in my opinion. But it's not worst case n plus m times log n plus m. It's like expected time. I don't know what the worst case is. I think the worst case is if there's a lot of collisions, it could be pretty bad. But you shouldn't have a lot of collisions depending on how you do it. And most of the time you shouldn't. The reason why I bring this up is that all of these questions, as you saw when I searched longest common substring, all of these questions are, that question is basically depends on on research that other people did. So if you're doing these questions quickly, then you're literally performing like researcher level research in like minutes, which should be impossible. Like you should not be able to do that typically. Now I can do something similar to that, approaching that, because I've been studying this stuff for like over a decade. I think I started really seriously working on like really hard questions that are like of research caliber difficulty, probably like a decade ago, probably around like 2013 or so, maybe even earlier than that, where I was like trying to do these questions without learning learning the research beforehand. Yeah, basically it should be almost impossible to do these things quickly. At least the harder ones, because they're literally like research. They're basically like conclusions from a research report. And unless you're doing, computer scientist research level work in like moments, which is like, most people are not capable of that, then you shouldn't be able to do these quickly. Now, if you have memorized solutions and you learned all that stuff, then those sorts of questions you can do them very quickly. It's not that hard at all. It's just a matter of, did you read the paper, and then did you apply what the paper, came up with. That's, especially like that longest common subsequence question. That's not substring, substring question. And I've seen that there's a few applications of that in the LeetCode problem sets. Now, there are other questions, though, that are not necessarily like research level questions, but they're just kind of like common concepts that you see repeated a few times. Those are usually the medium questions. That's why I like the medium so much, because they're tricky enough puzzles where you can figure them out, but they're not like too hard. They're not so hard that you have to go find a research paper to solve it. Some of them you can employ stuff to solve them, but it's kind of what it comes down to. Like, you basically just need to, like, what I would say, if you want to do these quickly, you've got to if you want to do like the hard ones quickly, you've got to do, and really the easier ones too, the mediums and the medium ones technically too have the same kind of thing. But you got to go to this, like a website like this, and just read through all the articles. And yeah, here's the navigation. You can just read through all the articles, and then you'll have what you need basically to solve pretty much everything quickly. You may have to practice a little bit to do them very fast. I don't know if I really recommend. I mean, it's fine, I would say, to learn this stuff and memorize it more or less. I mean, you basically have to memorize it. There's like no other way to. You could, in theory, look it up, but like it's not really. In an interview, they're not going to let you like look this up. Yeah, there are other questions, though, that are a little bit more unique than even these things, a little bit unusual. I think it just comes down to practice to come across those things. Like I've even seen stuff in the medium section that's like, they're not too hard to figure out, but it's very different from all of those papers. Like, this is actually a good question. This is like not really in any paper that I've seen. It's not really paper worthy kind of a thing. It's like just kind of, I don't know, you gotta like think about like the indices of binary trees kind of a thing. Gotta really ponder it. But anyway, yeah, that's my quick take on that one. I don't think you should be able to do these quickly. I don't think so. I appreciate that you like the stream. I'm grateful. Glad. Yeah, I think I'll stop here. I think for the night. This one was kind of rough for me. This one took me like an hour. The other ones I was able to go through them pretty quick, but this was a bit rough. Yeah, I mean, it's just like the ones where it takes you more time. I think it's really just practice. That's what it comes down to. The ones that like don't rely on a paper, that's something that you can kind of know or figure out. Like that one's just, yeah, as you mentioned, just a matter of practice. But the ones that are like research report, they like rely on a research report. Like you just have to read the report. Like if you want to do it in any reasonable amount of time, unless you're going to like reinvent that research on your own, which again, technically you can do. And I've done, as I said, I've done something similar. But really, in my case, it was like finding a different approach that's a lot simpler. It's just like finding a shortcut. Yeah. So what else can I say? Okay, yeah. So I'll probably stop here. But yeah, this is fun. Appreciate you all coming by and saying hello and watching. If you like the video, the stream, don't forget to give a like and subscribe for more. And I think I'm done here. I think I think I talked a lot in this video. The other videos have been like not talking as much because I'm just kind of try to churn them out and keep the video focused on the problem. But this is an interesting one. It looks like also, by the way, they recommend other questions. It looks like this question is probably similar. So anyway, all right, I'm gonna get going. So yeah, thank you. Take care.